There's a lot of learning of the personality of agents. As you said, that's a great example of an agent needs to tap into an app or an API and they need a login and they don't have the
Yep.
login, and then they fabricate whatever information was needed there. And that's a classic one, and I'm sure there's many other ones. What I want to understand more are the guardrails rules based,
Hmm.
or are they adaptive? I assume there's both.
So it's a mixture, as you said. So the first part is we do establish a definition of what you want to guardrail, right? And this is a set of allowed and prohibited behaviors, for example, that you want to permit your AI system to abide by. So that's spelled out typically by either a product owner. It could be legal risk and compliance that say, I want to specify these particular rules. Let's take the emotional inference in the workplace, which is specified in Article 5. A lot of our enterprise customers are interpreting that. What does that mean? What is allowed? Sentiment analysis allowed, but not using call recordings and doing sentiment analysis on call recordings. Maybe that's prohibited. So getting really specific about the particular description of that rule is something that our users can do. We also, by the way, we have inbuilt features to suggest different types of rules based off of initial starting point of, okay, I want to prohibit legal advice. What exactly does that mean? So we help the customers with that in our platform. But then the second part is actually, it becomes really challenging to specify all different edge cases in natural language. And so most of our customers, they'll try this kind of first start, which is they'll specify the rule in natural language, they'll throw it into a prompt template, but they soon realize that prompt template starts to grow larger and larger and larger as you have all these different exceptions. And all the way to the point where we just published a report that the cost of adding the guardrails onto your base model through prompt templating can actually increase the total cost of inference by over 2 to 3x. And this is actually something NVIDIA did a study too. They found a very similar number. So what we actually do to avoid this problem is we build these adaptive guardrails that are powered by a very small language model that's less than 600 million parameters. And what we do is we synthetically generate a bunch of edge case data that's going to challenge your definition of the policy, and think about all these different edge cases where your policy may or may not be in violation, or that your definition isn't clear enough to specify if this scenario is in violation. And we generate a couple hundred data points that gets reviewed, and then we fine tune an ultra lightweight guardrail model on those data points. And now you have a very focused model, but then when you deploy it into production, we're constantly monitoring that model and how it's doing. And so maybe no guardrail is going to be perfect. So maybe you'll encounter some edge cases in the real world in production that your guardrail misclassifies. It's either a false positive, it accidentally said it violated your policy when it didn't, or it's a false negative, it didn't catch what it was supposed to catch. And so you can continuously monitor and then retrain your guardrail over time as you're adding that feedback to the real life monitoring logs. And this is a perpetual process of keeping track of this. And this is the type of evidence that we find to be really compelling for legal risk compliance teams. And as we personally talk to a lot of regulators and policymakers, this is the type of evidence that they're actually really liking to see and appreciating when we present this to them.
Christian is the co-founder of Dynamo AI, the company that is focused on a huge need in this market, in this tech cycle, which is the need for guardrails in AI. There is a huge need to be able to integrate guardrails in ways that are customizable, in ways that are intelligent. We need intelligence, we need feedback loops, we need learning, and we need monitoring.